Okay, the lens magnification equation. This is going to give you the magnification of your lens, how big your object is going to be. Now your object can be small or big. If your object is small, your magnification will be less than 1. Okay, so small image, M is less than 1. Okay, if you have a big image, your magnification is going to be greater than 1. Okay, and that's what they're saying. This is like the definition. That's kind of what that that triple equals means. I kind of think of it as like super equals. So you have your object height or your image height divided by your object height, and then your which equals the negative of your image distance divided by your object distance. If you have a negative image distance, put the negative in, which will then make these positive. I'll show you how to do it in the example problem. Now, we've got the same thing. We've got our object placed 32 centimeters from a convex lens. That's our DO. We have a focal length of 8 centimeters. That's our F. And now they're telling us that the object is 3 centimeters high. So this is the height of our object. And we want to know how tall, this should say image. We want to know how tall is the image. And that's going to be our HI. Okay, so we know the following things. We know our DO is equal to 32 centimeters. We know our DI is equal to 10.64. That's what we figured out in the last video for this example problem. We know that our height of our object is 3 centimeters, and we want to know the height of our image. Okay. Now, the magnification equation has it has HI over HO, and they say that it is equal to negative DI divided by DO. So you can see that this is what we're looking for, and so we'll be able to just cross multiply and find the answer, and I'll show you how we'll do that. So let's go ahead and let's fill in our numbers. So we have HI over 3 centimeters equals negative 10.64 centimeters divided by 32 centimeters. Okay, and when we cross multiply, I know you guys have done this before. I had a teacher once. She called this peanut math because she said that these like two things that you draw look like peanuts. I don't know. I've seen people call it butterfly math, and then they like draw like a little, I don't know. I think it's a little stretch. But anyway, so we have HI and 32 centimeters go together. I'm going to go ahead and I'm going to put my 32 centimeters in parentheses, and that just makes it a little easier for me to tell that apart. And then I have negative 10.64 centimeters times 3 centimeters. And so, again, I'll just have this. And I'm going to go ahead and I'm going to multiply these two things. So I'm going to have negative 31.92 centimeters squared. And the reason I have centimeters squared is because I just multiplied these 2 centimeters as well. So now I want to go ahead and I want to get HI by himself. So I'm going to divide both sides by 32 centimeters. And so that'll make this centimeters cross out, and that'll make our squared cross out. And then we will get HI equals negative. And this is what you're going to get. You're going to get like 0.9975 centimeters. And I'm going to go ahead and I'm going to round up to negative 1 centimeters. Okay, so that's our HI. And you can see that this height, we have a -1. It's a little shorter than the HO, so that lets us know that we've got something in the range of possibilities. And then let's look at the next step, because we'll be able to see a little bit more with this -1. Okay, so we have, this one asks, what is the orientation of the image? This wants to know, is it right side up? Or upside down? Now, in our last part, we found that our image height was -1 centimeters. This -1 right here, this tells you that your image is upside down. Okay, so if you get a negative height, they're basically saying that like this is 0, and so if you have a height that's going in the up direction, it's going to be positive, and if you have a height going in the down direction, it's negative. So since our image is upside down, he has a negative height. Okay, so if you see a question like this on a quiz or a test, just get whatever your height is. If you have a negative, that means it's upside down. If you have a positive, that means it's right side up. Okay, and that's all you have to do to figure out if the image is upside down or right side up. Once you know how to draw ray diagrams, which I'm going to show you in one of the other videos, then you'll be able to go ahead and you can actually draw a ray diagram to see if it's right side up or upside down. But a lot of students don't like to deal with drawing ray diagrams because it's kind of tedious. So that's kind of a, then you can do the math. So you can either do drawings, which doesn't take any math but is kind of tedious, or you can do math, which does take drawing, but then it's a little more difficult. So either way.